In this problem, there was a rocket that was accelerating upward at 15 meters per second, or 15 meters per second squared for 5 seconds before experiencing free fall, and we're trying to figure out if the bird would be safe. You were asked to look at this solution and see if you could find anything wrong. And you may have looked and said, you know, I think it all looks good. And you didn't find any mistakes at all. They restated the question, put a diagram here, put in the correct knowns and unknowns, found a good equation with only one unknown, solved, got the right units, all makes sense, and said, yes, the bird is safe. However, the solution is not correct. Think about how long the rocket's going to go upward. Is it only going to go upward when the engines are on? When the engines are on, it has this acceleration of 15 meters per second squared. But it doesn't stop going upward the moment the engines shut off. Just like when you throw a ball upward, the ball doesn't stop going upward the moment your hand stops touching it. Once your hand stops touching the ball, then it's in free fall. It keeps going upward for a while. The same thing's going to be true here. So we need to draw that portion in. It's going, going, going. All right, so here we have the free fall portion, and during this part, that's when the acceleration is going to be negative 9.8 meters per second squared. And this is going to happen for an unknown amount of time. And so the beginning of this part is the end of that part. So we know that this height is 187.5 meters, and this initial velocity is equal to that final velocity, which we didn't find, but we can find that now. So we'll use this equation. Oh, not that one. Use the equation Vy equals V naught y plus AYT. So Vy, which is unknown, equals 0 plus 15 meters per second squared times 5 seconds. So Vy equals 75 meters per second. So that is also going to be the velocity here at the beginning of the second part. That's 75 meters per second. All right, so we need to find out how much time it takes for it to go up, but then we also need to find this y at the very top. There's not a lot of room down here, so I'm going to go ahead and write right here. So Vy equals V naught y plus AYT. I'm using the colors to keep this straight. This is for the free fall part. If you don't have different colors you're using, make sure you label what you're doing, that this is for the free fall part. It really helps when you tell your professor or whoever the reader is what it is you were doing. And so it just takes a moment to make that clear. So we know the velocity at the top is going to be 0. I actually didn't write that in. But the velocity at the peak is 0. And we know it was going 75 meters per second at the beginning of the free fall part. The free fall acceleration is 9.8. And we don't know how much time it's going to take. So we can calculate that, and it turns out that that's 7.65 seconds. So it's actually going upward in free fall longer than it's going upward with the engines on. And then we can apply this equation again, y equals y naught plus v naught yt plus 1/2 ayt squared. So y equals 187.5 meters plus, not 0, it's going 75 meters per second at the beginning of this time, 7.65 seconds plus 1/2 times negative 9.8 meters per second squared times, sorry about that, So times 7.65 seconds quantity squared, and then we get a number of 474 meters. And one mistake that students sometimes make is they'll take this 474 meters and then they'll add 187.5 to it. But that has already been done. We put the 187.5 here. If we had chosen this to be 0 and we get a number here, then we would add the 187.5 to get 474. But 474 is the final height, or the maximum height rather, and that's higher than 450, so that means that bird that's hanging out at 450 could get hit by the rocket, both on the way up and the way down, or both of those are a possibility. And so no, not safe. And this is really a kind of a squished solution here, but 474 meters is greater than 450 meters. So we show what comparison we're making so that the reader understands how we arrived at our answer, as well as giving the very clear answer.